Today's episode is brought to you by Modern Grower. Modern Grower is your source for time and labor-saving farm tools, such as the Paper Pot Transplanter, Quick Click Seeder, and the Jang Direct Seeder. Turn laborsome tasks into free time with tools by Modern Grower.
You know, through a lot of the work that you've done, let's say, well, we know a lot of cultivated soils are degenerative and they're low on that carbon saturation point. Are there specific plants or crops that are net carbon sequesterers? Like they are going to end up putting more in than they take out at the end of the day?
Okay. So that question, the complexity behind it, it depends on if you isolate a plant by itself without management associated with it is one story. If you manage, so the example that obviously comes natural would be a corn plant, right? You know, a corn versus a native, a switchgrass or a mix of native vegetation. Now, corn, if it is managed properly, can reach a significant amount of biomass that is accumulated, and it's still one of the king of the crops. It sequesters more carbon than a forest at saturation, because saturation meaning that has already growth. But even yearly, when you accumulate the woods, what does the forest brings in terms of sequestering? The leaves. Then the leaves come. So that's to put it in numbers. A forest sequesters about 8 tons, and a corn crop on average will be at least 20 tons. But is it a net? No, because corn uses fertilizer. And that goes down the drain already, the emissions and all the life cycle analysis, and we can go there. The perennials, we have, for example, one crop, Miscanthus gigantus. I don't know if you heard, it's one of the new bioenergy cellulosic crop. The yield is 50 tons, okay, naturally, so no fertilizer. It fixes somehow, it just does independent. So, and the amount of roots and rhizobium that it accumulates is massive. So that will go. The problem with Miscanthus is that can be an invasive species. And so DOE, the Department of Energy that has funded the bioenergy centers across the nations, has almost allocated. University of Illinois is looking at Miscanthus, Michigan State and University of Wisconsin are looking at switchgrass that has much more of a broad range of possibility of growing, but switchgrass on average would accumulate about 8 tons of biomass. So those are the natural behavior to answer your question. Yeah, big differences in plant. Wheat is 5 tons maximum, and half of that will be, could be grains. And so I'm talking about in general average total and the primary productivity of that particular crop. But I want to spend a minute on saying that people may not realize that nowadays the level of photosynthesis done through two things: improved genetics and management, basically spoon feeding a crop. We have reached the level of yield of corn of 600 bushels. So the average national is 170 bushels, and world record for the last 4 or 5 years has been in the range of close to 580, 50, and 600. The last one, 615 actually, which when you convert it into total biomass, we're talking about now 50 tons per hectare. But the amount of, that's very positive emitter because of the amount of, it doesn't accumulate carbon per se because of the balances through the amount of inputs that they are used. As I initially said, Diego, with agriculture being an anthropogenic component to the climate, is through fertilizer addition, we lose 50% of the greenhouse gas emissions coming from agriculture come from N2O emissions, okay? And so that's another balance, because even the potential of total accumulation of carbon still requires nitrogen to go with it. There is a CN ratio. So you will always be depleted by nitrogen unless you add fertilizer. So if you want to fill all the soils with 5% in the globe, it will be equivalent to have 75% of the fertilizer production that we currently have in the world, which is really, really heavy sorts of emissions. Now, that doesn't mean that fertilizer has to come from synthetic fertilizer. There are legumes that can be produced. So if we want to come back to the species, yes, different species have different capacity, have different photosynthetic capacity and rates of accumulating carbon per unit area. The amount of this carbon, remember, there is a component above the plant, but there is also roots. So there is this root shoot composition that actually, in situation where water is not available, roots become deeper, and so they basically the plants provide these feedback mechanisms of saying, okay, the root says there is actually a simple way to think if plant is exposed to a stress and the stress comes from above, what would be a stress coming from above? Reduced light, right? Shading from, then all the synthetic the assimilates will go to the top, and the plants will try to go faster, try to elevate. If the stress comes from the soil, the soil gets the priority. The part of the plants in the soil. So if there is a water stress, plants doesn't grow higher. Actually says, okay, no problem. I'm gonna invert. Shuts down the photosynthesis. Some of the assimilates go down to the roots because remember, it's not photosynthesizing, but the roots are growing because they are desperately in search of water, and so you get more roots that way. So this mechanism changes by species. But to your question, yes, different species, different capacity. And I made a separation at the beginning, depends how they managed. So if corn is managed with no fertilizer and it lets grow for so many years, it would be far from getting 600 bushel. You barely get 100 bushel at the end because you run out of the corn is a very highly consumptive crops because of the sizes, and it doesn't fix nitrogen on its own like miscanthus or actually switchgrass does pretty well without fertilizer. So there is that mechanisms that complicates even things.
Hey there, guess what? If you're a farmer, you can have your low tunnels paid for by the NRCS. They have this cool new program where farmers can get $4 to $5 for each square foot to help with a Quick Hoops low tunnel system, frames and fabric included. It's like free money to help you grow more stuff on your farm. Want to learn more about Quick Hoops and the NRCS program? Click on the link below.